السلام عليكم ورحمة الله وبركاته. محاضرتنا اليوم تتحدث عن Linear Accelerator in Medicine، المعجل الخطي المستعمل بالمعالجة الشعاعية في الطب. Objectives: 1. Discuss the sequences of basic linear accelerator. 2. Describe the functions of the components. Introduction. Particle accelerators is divided into betatron, cyclotron, synchrotron, linear accelerator. How the idea was started: produces radiation that is referred to as high energy X-ray for patients with cancer. In 1928, Wade demonstrated that electrons could be accelerated through a tube by applying a radio frequency voltage to sections of tube. The linear accelerator is an extension of Wade's idea. The name linear accelerator comes from the fact that electrons are produced in the machines and accelerated in a straight line. How it works: used to treat all parts and organs of the body. Uses microwave technology to accelerate electrons in the part of the accelerator called the waveguide. Then allows these electrons to collide with a heavy metal target. The high energy X-rays are shaped as they exit the machine to conform to the shape of the patient's tumor. X-ray treatments are designed in a way that destroy the cancer cells while sparing the surrounding normal tissue. High energy photons enter the patient's body and aim to break the DNA in all the cells while the treatment area. In all the cells within the treatment area. The good cells are able to mend themselves. The cancer cells are unable to do this and therefore die. Patients lie on a movable treatment couch which can move in any direction. The beam comes out from the part of the accelerator called a gantry, which can be rotated around the patients. Radiation is delivered to the tumor from any angle by rotating the gantry and moving the treatment couch. So the linear accelerator is a device that uses high frequency electromagnetic waves to accelerate charged particles such as electrons to high energy through a linear tube. There are several types of linear accelerator designs, but the ones used in radiotherapy accelerator electrons either by traveling or stationary electromagnetic waves of frequency in microwaves region. There are two types of beam mode. One is called photon beam X-ray, gives 4 megavolt to 22 megavolt, single beam dual beams. And the second is called electron beam, gives multi-beam with energy group between 4 to 22 mega electron volts. The difference between traveling wave and stationary wave accelerator is the design of the accelerator structure. Functionally, the standing wave structure provides maximum reflection of the waves at both ends of the structure. Then the combinations of forward and reverse traveling waves will give rise to stationary waves. And the other is the traveling wave structure requires a terminating load in order to absorb the residual power at the end of the structure, thus preventing backward reflected wave. This is a block diagram of a typical medical linear accelerator that shows power supply, modulator, magnetron or glyceron, waveguide system, electron gun, accelerator tube, treatment head, bending magnet, and the treatment head either straight beam or bent beam. The major components of medical linear accelerator is power supply, modulator, magnetron, glyceron, electron gun, waveguide system, accelerator tube, bending magnetic, treatment head, straight beam, treatment head, bent beam. And this is the components for modulator, electron gun, flattening filter, cross-section of accelerator tube. Power supply provides DC power to the modulator. Modulator delivers the pulses to the electron gun and the magnetron or glyceron. Then the accelerator tube or structure via a waveguide systems. Linear accelerator is divided into 4 groups: the accelerator, the table, the collimators, and portal imaging. This picture is showing the bending magnet, target, accelerator, waveguide, electron gun, flattening filters, foils, transmission ion chambers, and multi-leaf collimators. This picture shows the photon beam path and the other components. In this case, electron beam accelerated in the waveguide, and the components are X-ray target, flattening filter, electron scattering foil, secondary collimator jaws, X-ray beam, center axis, accessory holder slot, forward peak X-ray beam. And the second type of beam path is electron beam path, and the accelerator electron beam, and the components are scattering foil, transmission monitor ion chambers, accessory mount, electron cone or applicator, electron beam, center axis, and X-ray target removed. Now we have 5 quizzes. 1. Write in detail the components of linear accelerator. Quiz 2. Describe the work of linear accelerator. What are the functions of multi-leaf collimators? Define the following linear electron gun. And quiz number 5. What are the differences between photon beam path and electron beam path? And finally, this is the references of the lectures. Thank you.